Hey everyone, this is Steve Bishop from ProgrammingMadeEasy.com, and today I have got a special guest for you guys. I have the one and only Jeremy Clark. He is one of my favorites to watch. Most of you guys probably know I do have a Pluralsight subscription. I watch Pluralsight videos all the time because it's really one of the best places I think to go to find some information. But as I go through the library of different videos, I find that there are certain authors that I really like watching. There's one of the good ones I think is Scott Allen. He's got some great stuff, especially on ASP.NET and ASP.NET Core. So I love his series. Also, John Sonmez, who we've had on the show earlier too. I really like some of the stuff that he has. But I really got to say that Jeremy Clark, who's on the show today, I really like him because he has not just a good presentation. He doesn't have just good material, but the way he talks about things is in a much more expressive way so that you follow along. He doesn't rush things. He doesn't just, kind of throw a whole bunch of technical stuff at you. He actually goes through and explains things to you. And that's really one of the reasons why I wanted to have him on the show. And I went and I guess I kind of stalked him a little bit. He came down here to Phoenix and he did a presentation on practical reflection, which was a really great presentation. And he's got some information on that on Pluralsight. He's already got a course on that, but I'm pretty sure you do presentations all across the US about that. Anyway, ladies and gentlemen, this is Jeremy Clark. Say hello.
Well, thank you. Yeah, you're going to make my head really big if you say that. I think the thing is, the stuff I talk about is all stuff that I had trouble with as a programmer and then became really important to me. And so I think that comes across in the way that I present it, because it's like, okay, here's the stumbling blocks that I had, and what can I do to make sure that other people don't have them?
Yeah, exactly. That's, I think, what started me with my channel was I was trying to learn Access, and Access is one of those things that there's some pretty good information out there, but it seemed like it either wasn't, it really didn't go through things in a thorough manner, or didn't really explain everything. It just kind of did step by step. And I really felt like there was a missing element here. And I was just kind of getting started with Access. I'd programmed in something else entirely way earlier on in my life. But Access was this thing that I needed to learn for work. And I was trying desperately to find some information. It was really hard to find. So I just decided, maybe I should start posting some videos about my trouble, about my struggle, and try to work through all these things. And it's been really, really great. So I think you're exactly right, Jeremy. Being able to just talk about the problems that we encounter on a day-to-day basis when we go through development is really important. Which is why this video is actually going to be a little bit different than my other interview videos. I hope you guys are ready to actually look at some code, because we're going to do some coding in this video. It's going to be a little different than my other videos. That's why it's not titled "In My Opinion." This is not an opinion-based video. This is actually, we're going to be doing some code. So, Jeremy, why don't you talk a little bit about the code that we're going to be doing today?
Oh, I love code. For anyone who comes to any of my presentations, you'll know that usually I have like 3 PowerPoint slides and then the rest is code, because that's how I learn well. And I know a lot of other people learn well that way too. Today, I'm going to show something. This actually came out of a project that I was doing for home automation software. And my brother, who gives me stuff to frustrate me, about 10 years ago, he gave me an X10 home automation kit, and it came with a little serial dongle. And he's like, "You'll have fun programming to this." So after a lot of struggles and trying to figure out, how to send RTS and CTS bits through the serial port, I finally got it working. So I did a rewrite of this software probably about 2 years ago now. And one of the things that I came across is I was listening to someone on a podcast talking about home automation, and they're like, "Wouldn't it be cool to have like the lights go on or off based on sunrise and sunset times?" And I'm like, "Yeah, that would be really cool. Okay, I need to go write that now." And so what I did was I went online and I found a service that would provide sunrise and sunset times based on a GPS location and a date. And I'm like, okay, this is cool. But it gave it back in JSON data that was just a string with the time, and the time was UTC. So I had to somehow figure out how to get that into my system. And my first attempt was just a horrible, horrible mess, but I got it working. And then I went back later to do some basically TDD experimentation with this, because I got stuck the first time through, because I'm like, well, I don't know what I'm doing with this particular service call, so I should TDD into it because I think that would be a good approach. But I kind of got stuck on step number 1. And so I didn't do it that way. And again, I kind of created a horrible mess that I later cleaned up and added tests to. But then later I'm like, okay, I need to figure out kind of what's a good approach to this using TDD, and see if I TDD into this, how will those results compare to what I did when I did it manually and then kind of cleaned it up later. And I found that TDDing into it actually gave me code that I liked a little bit better than what I had ended up with, even the clean version. And it actually did get me there faster. Now, granted, I did have the, I already knew how to do the solution. So I don't know
Right. That
how much
always
of that
helps when you
speed.
know how something is supposed to work.
Yeah, but definitely getting the cleaner code to start with, that was kind of a big deal. So um, the interesting thing about this code is no longer in my home automation software because the service stopped working.
Well, did you make it an interface so that you could then plug into
Actually,
some other
I
service?
did. That was a key thing that I did, because I love interfaces. As you know, I have a Pluralsight course on C# interfaces, and I didn't like relying on this third-party thing to start with. So I'm like, you know what? I'm going to put an interface here so that if I do need to swap this out for something else, I can. And it was really great, because the day that I went in to go and just make some updates to the system, and the system wouldn't run because the service was down. It was throwing 503 errors. And I'm like, okay, let me swap this out for a library that a friend recommended to me. And so now I'm using this library that I got through NuGet rather than making a service call for this particular functionality. But I think that this is still a good way of kind of showing how do we take apart one of these problems, because, you know, making a service call or a database call, that's something that we do all the time. So I figured that this would be a good way to handle it. So
well, and thank you for putting this together. I know you haven't actually presented this presentation yet. So for those of you who are watching this video, this is the first time that Jeremy's actually even going to demonstrate this particular problem and the solution. So if it's a little rocky here, please bear with him. You know, I'm sure he's done this presentation in his mind and, you know, practiced it at home several times, but doing it the first time live especially is probably a little bit more nerve-wracking than having something that you've done multiple times already in other presentations, right?
yeah, I over prepare. So I have done a lot of practice with this, and I have actually kind of done an alpha version of this presentation. So it's not completely new, but, you know, I've been speaking for 7 years now.
I'm just so offended that I'm not the first. Come on, Jeremy.
Well,
I feel lied to.
The first time was really rough, so you're going to get the better version.
Okay.
The version you wanted.
Well, before I get started, I just wanted to let everybody know a little bit about you. I don't want to take a whole bunch of time. I know a lot of people are here to watch code, so I get that. But I do want to at least give everybody the opportunity to find out how to learn more about Jeremy. He's got a great blog. So Jeremy, tell us about your website, how they can get in touch with you. You know, are you writing any books or anything?
I have not written a book, although I keep having people tell me I need to write a book. And everyone I know who wrote a book said, I'm glad I did it, but I'll never do it again. So, and books are kind of on their way out. I mean, I hate that because I'm a book learner. That's how I learn. I love books.
This coming from an English major? No.
Yes, I love books. And I found I don't learn well from video, which is unfortunate since I do have access to the entire Pluralsight library as well, but I just don't learn well that way. So online, I'm at Jeremy Bytes. so BYTES, and you can pretty much find me everywhere there. So my website is jeremybytes.com. There's a link to my blog from there. And then on Twitter, I'm at Jeremy Bytes as well. And I try to blog about stuff I'm learning. So I've had a couple articles recently about doing some testing with an F# library called FSUnit, which has been intriguing. And I've been doing more explorations into the functional world lately. But there's all kinds of good stuff out there. And then I love to speak. So I might be in a town near you sometime. I think I did 32 events this year, and I have one more next week. I've been on way too many airplanes. I think I've been on 37 airplanes this year. So it's been fun. And I love to speak and love to watch people learn. So that's why you'll often see me in person. And then, of course, I'm available to do workshops for your company. So if you want me to come in, do a 1 or 2 day workshop, spend some time doing code reviews, best practices, things like that. That's what I really love to do.
Well, and I have been present for one of those presentations. He did a really good job of talking about practical reflection, which reflection is one of those kind of a hot button issues. There's some people that really like it and some people that really don't. So I think again, practical applications for these things, practical applications for TDD. That's again, one of the reasons why I really wanted to bring you on, Jeremy, and why I'm so thankful that you did. So one last question that I just kind of wanted to pop in here before we get started with the code is, since one of the things that a lot of people know about you is that you were an English major, but you weren't really into programming all that much. It kind of happened later on in your life, which I think speaks to a lot of us older guys that we kind of got into this a little bit later on in our lives. So tell us just real, I guess, as quickly as you'd like to, how did you go from being an English major into doing development?
So I've always been a hobby programmer, and that goes way, way back. I think I figured out my first programming experience, and this was in 1979. So that gives you an idea of how old I am. And I got this awesome Christmas toy called a Big Track, which is basically kind of this programmable tank. But it was like the world's most horrible programmable tank, because basically it had a keypad on the back and you would punch in the commands and say go. And then, of course, it would never do exactly what you wanted it to do. So you'd have to do it again. And the thing is, there was no way to edit commands. So you had to put the whole thing in over again. So it was a horribly frustrating experiment in programming by trial and error just to get this tank to drive around the coffee table in the living room. But for some reason, I love that toy. And then later on, I did do some programming on an Apple II. And then I think the first thing, my brother worked for a software distribution company. And one time he comes home and he has this big giant box, and he's like, here you go. And it was Borland C++. And so I installed that on my computer, which was a 286 at the time. I don't even know. Do people know what a 286 is?
I do. Yeah.
And it didn't even have enough memory to run the graphical. It was a TUI interface, so it's a text UI. So it was DOS based. So I had to do everything from the command line and text editors. And somehow I didn't give up on that. I didn't really think of it as a career, though. Through college, I actually started out as a math major and then changed to an English major. I think everybody is supposed to change their major at least one time in college. And it was actually a really good option. I wasn't looking at college as career training. And the English major, especially when you talk about literary criticism and things like that, there's a lot of analysis, there's a lot of problem solving, and there's a lot of figuring things out. And so I know that those critical thinking skills really helped me later as a programmer. So after college, I had to get a job. And kind of my first real job
Oh,
was working.
reality. Dang.
Yeah, reality.
Oh.
Hate reality. So I ended
Well,
up working hotel reservations for the Disneyland Hotel. And that's how I got started as a programmer.
huh. You did reservations for Disneyland, huh?
Yeah. So what happened was at that point, I thought about getting into programming as a career. And so I knew I had kind of enough technical knowledge to get started, but I didn't have anything on paper.
Mhm.
So I thought about going to like one of those really bad tech schools that are all shut down now. And I'm glad I didn't. Eventually, what happened is I ended up on the user side of a multi-year project that the development team was working on. And in those various meetings, the developer manager again kind of saw that I had those critical thinking skills and kind of the right mindset. And so she offered me a junior developer position. And that was, after I'd been working at the Disneyland Resort for 6 years in 2 positions in different departments. And it was an awesome team. So a lot of really smart senior developers who love to share and learn. And I grew so fast there. But, I was 29 when I started my professional career. So it wasn't, something that started when I was very small as far as a profession's concerned. Um, and then just stuff happened from there. And now I'm an international speaker,
Yeah,
which is cool.
and you've done fairly well for yourself, I think. Based upon what I see as far as the content that you put together, I really, like I said at the beginning of this show, I really enjoy your stuff because we're in a constant state of learning. It's not something where you and I are ever going to be fully filled up with all the knowledge that we're going to need in this industry. So I think this
Yeah.
exchange and giving back and forth of information is really, really important to the industry, not just ourselves. It's important to the industry because that's how you get new ideas and stuff. And if you can have a real presentable way that you do it, it's really important because, just handing out, especially for guys like us, we're so technically minded, it's sometimes very difficult to be able to talk about things in such a way that everybody's going to follow along and understand. I did this in IT too when I was doing tech support. People would ask me, why isn't this working? And then I give them the answer, and their eyes would just gloss over. And so you have to be able to talk about things in such a way that it's going to relate to people, and it's really important. And Jeremy does a great job, as you guys are about to witness here. So. Jeremy, whenever you are ready, let's go ahead and do some screen sharing.
Okay, let me see if I can get this guy going. And we'll go here.
Huh? What is that application you have open there? Is that Visual Studio?
This is Visual Studio. I am primarily a C# developer these days.
Okay.
And it's all kinds of fun. So like I said, I have this service. What I did was I replicated this service. So you can download this code from my website, and I'll make sure I have links available. So there's this solar calculator service that is what's hosting the service. So I basically recreated that online service, although I did it with local time rather than UTC, just to kind of simplify this example a little bit, because date time, man, that's a whole nother thing.
Yeah, they have special libraries to handle that kind of stuff.
Yes, and I always defer to my friend Matt Johnson about that. He is Mr. Date Time, and he's done all kinds of cool stuff in that world. So let me just run the service so we can take a look at what this is. So let me just go ahead and start this without debugging and make sure it's in a browser window that you can see.
Is that Spybot down there? You still run Spybot, huh?
What are you looking at?
You get a little Spybot down there at the icon. It's interesting. I haven't seen Spybot icon in a long time.
I don't think so. This one?
No. The little spyglass. Is that a magnifier?
Oh, this one. Oh, yeah. This is Zoom It.
Oh, Zoom In. Okay. Gosh, that looks okay. Doesn't that look like the old search and destroy Spybot? Man. Sorry, I catch these things. Go ahead, Jeremy. I apologize for interrupting.
Oh, no worries. I want this to be a conversation because I get tired of listening to myself talk. So let me go ahead. I've got some sample URLs here. So we can paste in this cool URL, which if we look at it really closely, actually, I don't know if the zoomer is going to work. I'm going to try it.
It's pretty big.
Oh, no. Okay. That
Oops.
kind of messed everything up. Okay.
So-
but if you look really close at the URL, the URL actually has a latitude, a longitude, and a date as the parameters.
Yeah.
The result set is very big, yes, and that's on purpose.
Yeah.
And so we can see that this is for 11:30 at more or less my location. It's not my exact GPS coordinates because I don't want you to come knock on my door. But people know I live in Anaheim, so this is actually the coordinates for Anaheim City Hall. So if you'd like to go to Anaheim City Hall, those are the GPS coordinates.
Those are the GPS coordinates. Gotcha. Okay.
And so you can see we have sunrise and sunset times here. And then if we were to put in some bad data, I've got some basically a bad GPS coordinate in this one, then it returns an error.
Okay. So let's just real quickly set this up because I'm not sure that everybody's quite caught up on what we're doing here. Jeremy's got a service, a pretend service. He's actually running it himself, but you can imagine that this is some third-party service, some third-party host that is presenting this data about when the sunrise is and when the sunset is, and date and time, and based upon the date and time that he asks and the position that he is at, what is the sunrise and sunset exactly, so that he can use that for an application that he's going to put into his home to manage when the lights turn on and off. So just that's what we're looking at here, is the actual resulting data back from the service, that third-party service, and it's in JSON format. That's why we have the curly braces and the quotation marks and all that good stuff.
Yeah, so we've got the JSON result here, and basically what I want to do is I want to take this value here, which is the sunset value, 4:42:49 p.m., and somehow turn that into a date time object that I can use in my code, so that I can, like, for example, right now I have things set up so there's certain lights that go on a half hour before sunset. So if I have the sunset time, I can get that as precise as I want it to be. Doesn't really need to be down to the second, but I get it kind of close enough. So the problem that I have is how do I actually, kind of TDD into something that I can use? Now, like I mentioned before, I do have an interface for this so that if this third-party service stops working, I can swap in another library, hopefully without too much hassle. So this is basically, the interface is called iSunsetCalculator, and there's a get sunrise and get sunset method that both take a date value, and that would be just the date portion. So for example, November 30th, 2016. And then it will return a date time, which includes both the date and the sunrise or sunset time appropriately. So again, having this interface in there makes it really easy to swap this out for another implementation if I need it. But this is basically the interface that we need to conform to create our library. Now I'm kind of really starting from scratch. So to set things up, I'm going to add a couple class libraries to this project. The first one will be the library that I want to use, which is my actual production service. And I'm going to call this Service Sunset Calculator. Or I'm sorry, actually that's the name of my class. I want to call this sunset.library. That will be the name of my library. That sounds better. And then I'm going to do something that I know you're not supposed to do in TDD. I'm going to write some code before I do anything else, and that is I'm going to name this Service Sunset Calculator. I'm very much of the practical TDD approach, meaning don't take it to an extreme.
And I completely get that. If you already know what you want it to be, then it's usually a good idea to go ahead and do that. One of the things that I like to do is just use foo and bar use foo for my class names, bar for my method names or property names. If I don't know what they are yet, just name them foo and bar so that I have something generic that I can go back through and say, okay, I didn't really have a name yet for what this is, but now that I've vetted it out and what it is that it's going to do, now I can go back and rename it. So if you know ahead of time, like Jeremy here, what your class is going to be named, because it's just already been predetermined. Maybe you've got someone else in your office that says this is what it needs to be named, based upon the requirements, then, by all means, you don't have to use TDD to go name your classes. But if you're really, really starting from scratch and you don't know what the name of a class is going to be, just foo and bar. It's really helpful to just have something to just name it and then go back and do the renaming.
Yeah, and that's really part of the whole TDD process, because we're going to be doing red, green, refactor. So red, write a failing test; green, get that test to pass; and then refactor is cleaning up those variable and method names if we need to. It's going in and rearranging code if we need to once we have working code. So yeah, we don't have to feel like we're married to any name that we kind of start out with. So this will be just the class that I start with. Now I'm just going to create a class library that's going to hold my tests. And I'm going to name this the same as the library. So sunset.library.tests will be the name of this. And then for the class that I'm going to use, I'll name this to also kind of mirror my service class. So we'll call this service sunset calculator tests, which is really long and
Oops, you
has a
get
typo
two
in
S's
it.
there in your tests.
Yeah, I really like S's apparently.
Or at least your keyboard really.
But that's the cool thing about all this refactoring stuff that's built into IDEs. I love powerful IDEs.
Oh, yeah.
So for my test library, I'm going to add some references. First, I'll bring in the interface and the library, because I know that I'm going to be using those. And then for testing, I like to use NUnit these days.
Mm-hmm.
So I'm going to grab that from NuGet. So I'm just going to come up here, type in NUnit.
You like those parameterized tests, right?
Yeah, I like the way parameterization works. I like the way that exception handling is built in. And those are kind of the primary things that I like over MS Test. I used MS Test for many years because it was there.
Right.
Before NuGet, it was a lot harder to kind of use a third-party testing library, because then everybody on your team had to have the stuff downloaded and installed on their machine and blah, blah, blah. So it was easier to just kind of use what was there. So I'm just going to grab NUnit 3.5, and then there's also the NUnit 3 test adapter. And what this will do is it will plug in to my Visual Studio Test Explorer, so that when we run the tests, we can see them inside Visual Studio. We don't have to use a third-party runner.
Right. Yeah. And that's another reason why I think a lot of people stick with MS Test, at least early on, is because you get the neat little Test Explorer window that comes right with Visual Studio. So if you can plug in NUnit, like you were saying, if you can get NUnit real simple now with NuGet, and then you get your test runner essentially built right into your Visual Studio window instead of having to go get a third-party test runner. That makes things pretty convenient, because then you can see all your results right there on the one screen.
Yeah, and I love integrated environments. I know that it's kind of trendy to be headed towards the kind of the lightweight editor and other tools in the tool chain, but man, when this stuff works together, it's brilliant. So I'm just going to create a sample test. And for that, in NUnit, you attribute it with the word test. You'll notice that I have red squigglies, and that's because I need to bring in the using statement. So I'm just going to hit Control Dot and let Visual Studio do this for me, because I am a totally lazy developer. So it says, hey, do you want to add NUnit.framework to your usings? Sure. Okay. I love that stuff. So we'll just do a sample test here, and I'm going to assert pass, just because I want to make sure that my Test Explorer is working and everything's plugged in.
Right.
So I just rebuild, and hey, look, there I have a passing test.
Yep.
Now, one thing you'll notice is my test ran automatically. This is the world's greatest button. Unfortunately, this is not available in the community edition of Visual Studio, but it is available in the other editions. And it's a toggle button that says run tests after build. So when that's
Ah,
toggled down, every time I build my application, the affected unit tests will run automatically.
hmm.
Woohoo, I don't even have to click a button. I love that.
That is nice. That is kind of nice.
Okay, so now that we see that stuff is hooked up and that my test runner is working and all that, let's go ahead and start TDDing into this. Now, I kind of said the first requirement is that my class needs to implement the that particular interface, right? That iSunset calculator interface that we saw.
Right.
So I'm just going to write a test to check that, and we'll TDD our way into getting that implemented. So I'm going to, when I name my tests, I like to name them so that I know what goes wrong by just looking at the name of the test in Test Explorer. So if a test comes up red, I should be able to look at the name and know what went wrong rather than having to dig into the code. So I'm going to call this Service Sunset Calculator, which is the name of the class we're testing, calculator. And then I'm going to say implements iSunset Calculator, which is the name of my interface. And we'll get rid of this guy here so we've got a little more space. And then in here, all I need to do is new up an instance of my Sunset Calculator. So we'll call that calculator, new service Sunset Calculator. Now, one interesting thing is you'll notice I didn't have to bring in a using statement for that.
Mm-hmm.
And that's because NUnit is just really smart about saying, oh, well, you've got these assembly references already. I'll just let you access whatever you want from them. And boy, I'm typing very badly today.
Yeah, you don't get that kind of thing with MS Test. So that's.
Yeah, there's kind of a lot of, well, MS Test kind of, at least the desktop version is kind of stopped development. There's actually a different version for UWP, and that one is still kind of actively being developed, but it's still kind of far behind NUnit and XUnit.
Yeah.
Now,
Yeah. I just kind of wanted to say here real quick, MS Test is a really good platform if you're just trying to get started with testing, because everything's all built in, but you're going to run into situations and scenarios where you're going to realize, well, there might be a better way to do this. And NUnit and XUnit are really the predominant testing frameworks now because they have gone beyond the basics of what MS Test does. So if you guys are really interested in trying to do test-driven development, I really would strongly recommend NUnit. I think is probably by far the most widely used right now. XUnit's still kind of out there. But I definitely NUnit, I think, is the main one you should probably be going with.
Yeah, I've actually heard the opposite, where a lot of open source projects are using XUnit for their tests.
Oh.
So yeah, I'm not sure which is correct, but I don't know that correct is the right word.
Yeah.
I started using NUnit, got used to it, and I did successful testing with MS Test for many years. So again, there's ways to do things. There's just these frameworks can make things a lot easier.
Yeah, a lot easier.
One thing is the assertions. So NUnit has a whole bunch of extensions on the assert class, more than you get by default. And so I'm going to use this cool one that's called is instance of. And I can say, is this instance of an iSolar calculator or Sunset calculator? Calculate. Boy, I just cannot type to save my life today. And again, I'm going to hit Control Dot to bring in the using statement for the interface.
Yep.
And then we'll just pass in our calculator for that. So this will say, does this object actually implement this interface? And of course, the answer is no. So we should end up with a failing test.
Mm-hmm.
And again, by looking at the name of the test, I can tell what went wrong, right? So I can say Service Sunset Calculator implements iSunset Calculator. Okay, that's not passing, so that must be the problem.
Right.
So let's go ahead and write the code to get this to pass. So we'll flip over to our code. We'll say this is an iSunset Calculator. And then again, Control Dot. One thing I didn't do.
I forgot to bring in.
Yeah. Add a reference.
Add a reference. Yep.
I need a reference to the interface. Yeah, that's dangerous because actually I'll show this. The Control Dot option here says, hey, do you want to generate a new interface? And it's like, no, I don't want to do that. But I have done that a lot of times. So I'll add a reference to the interface project. And now our magic pop-up should say, add a using statement. Okay,
There we go.
that's good. Now, if I try to build at this point, it's going to say, hey, you can't build because
You
you're not
haven't
actually
implemented it.
implementing the interface. And a build failure is a red in our world, so we're still red. I'm
Yep.
just going to click. So my cursor is on iSunset Calculator. I hit Control Dot. Hey, do you want to implement this interface? Yes, please. And man, I'm a lazy developer. I love that kind of stuff.
Yep.
Now when I build, I'll see that my test actually passes. So even though I'm not doing anything useful, I am implementing the interface, and so I have a passing test.
Right.
Now, this is where I kind of got to the stuck part, because I'm thinking about, okay, I have this get sunset method. Where do I go next? Because basically, I need to do three things. I need to call the service, get data, and then I need to parse the sunset value from the data, and then I need to convert sunset value to a date time. So those are kind of the three things that we need to do based on the data that we have. And the problem is that the first time I tried this, I'm like, okay, well, let's start with the service call, because that's the first thing we have to do. But that just got me into trouble, because first of all, you can't really TDD into a service call. You can kind of do some things around it. But if you focus on this, you're just going to say, I can't write any code because I can't get data from the service. But what I discovered is, hey, if we start maybe not with step one, but maybe the simplest thing that we need to do, we can work our way out. And so what we're going to do is we're actually going to start with parsing sunset from the data. And as a reminder, here's our data. And so basically I have to figure out, how do I parse this JSON result? And so for this, what I'm going to do is I'm just going to take this value and bring it into my code. Now, I don't actually want to just paste this into my code, because it's got a lot of quotation marks in it. And takes a long time to escape those. So I'm going to use this cool website called freeformatter.com, where I can paste in this string and I can escape it, and it'll put all those backslashes in it for me.
Oh, nice.
Oh man, that has saved me so much time over the years.
Yeah, lazy. You know what? You keep saying you're a lazy programmer, but I remember there's a pretty famous quote out there from Bill Gates himself that says, I want lazy developers because they're the guys that find out the best ways to do things.
Yes, and lazy, not careless. There is a difference.
Yes, there is a difference. Yes.
So now I can easily, in my test, create a string called good data that we can use for testing, and it's already escaped in everything.
Right. So you're basically bringing in data. You're bringing in test data without having to actually call the service to get the data.
Correct. Because again, step one, what I want to do is I want to try to parse this string out of this result.
Right.
So rather than focusing on the service call, I'm going to say, hey, let's focus on what's coming back from the service.
You're essentially removing the integration step, because I assume you're going to leave the integration towards the end of this. But you're essentially creating your own fake data, your mock data, if you will, and you're making it yourself, and then you're going to be able to run your own tests against that data.
Yes, that's exactly right. There's people who talk about inside-out testing and outside-in testing. Quite honestly, I haven't read enough of those articles to know exactly what this is. I just know you don't have to necessarily do things in order.
Right.
So that's what I focus on here. Okay, so let's see if we can get something out of this string. So we'll create another test. And in this case, I want to parse the JSON sunset value. And then when I have good data, I should get the, should return the expected string. Not real happy with the name of that test, but that's okay, because we can change it later.
Yeah, you could just rename it later, yeah.
So in this case, what I'm going to say is, again, this is the value right here that I'm expecting. So we'll call it, we'll create a string called expected. I'll set it to that. And then what I like to do is think about, how is this method going to be called? Well, since we're basically passing in this giant good data string and getting another string out, this can be a static method. So there's really no need to have an object for this. So I'm going to start by thinking about, well, let me put a static method on this service sunset calculator class. And if I decide to move that to another class later, because it makes more sense, then we can do that. But it's something that'll get us started. So again, the idea is that I want to string back, and let's just say service sunset calculator dot, let's say parse sunset. I'll just make up a name, and then we'll pass in data that we have here. And then for our assertion, we'll just expect that the expected and the result are actually equal.
So just to clarify here, I just want to make sure everybody is aware. He has not written any code to fulfill this test. This is a test he's writing first, and he's thinking through, what do I want to be passing into my class or my function in this case, and what should I get back out of my function before I even write my function?
Exactly. We're basically saying, what do I want my code to look like when I call it? And you can see I've got red squigglies under that parse sunset method because it doesn't exist.
Right.
And if I try to build at this point, I will get a build failure, which is not a surprise. Again, I'm a lazy developer, so I'm going to let Visual Studio create this method for me. And again, this is one great thing about having these integrated environments. So in this case, I can press Control dot, and you'll notice I get a pop-up that says generate method service sunset calculator dot parse sunset, and it gives me a little thing and says, hey, I'm going to create a static method. What do you think about that? I think that's an awesome idea. So I do that, and if I flip over to my code, I can see that that is now stubbed out. And at this point, my code will build, but we'll see we have a failing test because this is throwing a not implemented exception at the moment.
Right. So one of the things that's really good about the test-driven development here is that you're really working kind of backwards. And we typically think of, how do I make something run? In this case, we're actually thinking about, what is the behavior I want to have happen? Your code, you're writing your test based upon the behavior that you want to receive back. What do you want your functions to do? What do you want your classes to do? And then you can write your classes and your methods to match that behavior. And that's kind of where the whole behavior-driven development, that could be a whole other subject altogether. But at least what I'm trying to say here is, he's writing a test based upon what he expects the behavior of a class to be, or the behavior of a method to be. And by working that way through, you can actually start to think more, using your imagination to, what is it that I want this application to be doing before I actually even write the code to match that.
Yeah, and this is one advantage. I don't want to say side effect, because it's kind of a primary effect, is that we don't have any code that we're not actually using. So
exactly,
that's another advantage that we get from this. Now, one thing about the Visual Studio generating this method for me, you'll see it was able to figure out the return type is a string, and it figured that out because I said, hey, I'm going to assign whatever's coming back to this to a string value. And the same thing with the parameter. I'm passing in good data, which happens to be a string. So it created a parameter of type string, and it actually gave it the same name as my field.
Right. So it was able to stub out the method based upon the requirements that you put in the test.
Right. And again, as a lazy developer, that is totally awesome.
Yep.
Now, I am going to use a JSON parsing library here, which I think everybody does. So I'm going to go back to NuGet, and I'm not even going to type anything in, because you'll notice Newtonsoft JSON is just like the most downloaded thing ever. So
Yeah.
I'm just going to click on that and add it to my project.
Us poor .NET developers, we have to abide by everyone else's rules.
Yeah. So I know that this good data is a JSON string,
Mhm.
and I want to figure out how do I get the data out of this. So for this, I'm going to use JSON convert, which is one of the classes from the Newtonsoft JSON. And it has a deserialize object method. So we can pass in this good data value that we have. Now, the thing is, this will return an object that has all of these values that we were looking at earlier. So it'll have a result object, and then, or results, I should say. And then inside of that, it has a sunrise, a sunset, a solar noon, a day length. And then there's also a separate status, which is a sibling of results. And I don't want to create a class that does all that because I'm a totally lazy developer, since I just want to get this one value out. So what I'm going to do is I'm going to create a dynamic for the return type. So this will be, this will be my dynamic data will be what's coming back from this JSON. Now, dynamic means that we're going to be able to pick things out at runtime rather than compile time. So I don't have to create this object that has a results property that has these nested properties in it. Instead of doing that, we'll just use dynamic, and I can say data.results.sunset. Now you'll notice I'm not getting any IntelliSense at all on that, and that's because this isn't going to be resolved until runtime. But I can take that value and say, okay, this is going to be my sunset string, and then I can return that value.
Yeah, you're essentially shortcutting something here. You just so that everybody's kind of on board here. The dynamic data type allows you to basically create any type of object at compile time. So is it compile? Wait, I hope I'm getting that right. It's runtime. Thank you.
Yes, this isn't resolved until runtime.
Yeah, that's right. I was thinking var, but dynamic is at runtime, exactly. So he's not actually going to be creating that object until the application is running. And because of that, he doesn't need to go out and create all the different properties and the different methods, or all the different members that would be required to make that object called data. Instead, he could just use the dynamic variable, because the compiler, or not the compiler, excuse me, the runtime, the JIT compiler, I should say, is actually going to figure that out for him and put that together. So he can be really lazy. He doesn't have to create the whole class that's going to be with all the members that he expects back from his data from his API.
And this is particularly, so again, the sample service that this came from, that service actually had like 25 or 30 different values that I was never going to use.
Right.
So I was just going to pick out the sunrise and sunset values. That's all I needed from this giant JSON object. So I didn't, again, want to have to create that class that had basically placeholders for all that other stuff that I'm never going to use. So that's a primary reason why I did it this way. Yep. So if we build at this point and watch our test run, we have a failure. But you see we have a different failure now. If we look at this, we see we have a runtime binder problem. And basically the runtime binder is the thing that's trying to parse our dynamic object. Now what I did was I changed this. So you'll notice this says results, and this just says result. And I do that all the time. And so you don't get any compile time warnings on this. It's all runtime. So if I change that to results and then we rebuild, what we'll see is now we actually have a passing test.
Yay!
So we're actually getting that expected value out. Okay, so that's pretty easy so far. So that is really our...
Can we just take a look back at the test real quick? So just so that everybody can look through this and work through this and what he just did. The string that's expected is the 4:42:49 p.m. He called the parse sunset, passing in the good data, which is the string that he has back up at the top of the class there. He's passing that string into the parse sunset, and he expects the result from the parse sunset method to be that 4:42:49 p.m. And in fact, the result of that parse sunset method was exactly what he expected.
Right. And what I'm doing here is when you're new to unit testing, I would highly recommend using the arrange, act, assert layout, which I actually did here. I just didn't mark them.
Yep.
And the idea is that we have an arrange section where we could set up any variables that we need or new up objects that we might need. And then an act section where we're performing the actual thing that we want to test. And then the assertions, which is where we check to see if our results are correct.
Right.
And if we look at R equal, we'll see that it has a number of overloads, but basically there's two values, expected and actual. So again, our expected value is the string we have above, and then the result is what's actually coming back from our parse sunset method.
Yep.
So we've gone through the red-green steps here. I want to do a little bit of refactoring because I don't like this parameter name. Good data is not a good name for a parameter because this is just what's coming in, right?
Right.
So I'm going to change this to JSON content. And then I'll hit Control Dot to just rename everything in there. So because that's a parameter name that makes more sense in this context. Yep. And then rebuild, let the test rerun, make sure we didn't break anything. Everything's still green. So that means we can move forward.
Yep. So what he's done there, everybody, is he's gone through the red, green refactor phases. The red was, of course, when he created the first test. Then he wrote the method, the parse sunset method, to get a passing test. Then once he had a passing test, he's just going through and just kind of refining the method a little bit to make sure that it matches up a little bit better with, how you cognitively want it to flow. So he's changing this parameter because it makes more sense to be JSON content than it was good string, or what was it? Good
data.
Good data. Yeah. So you always want to be doing this three-step process. You create your test that fails, and then you create a passing function or class to make that test pass. And then you go back and you refactor, and then you want to make sure you test again, you run that test again to make sure that your refactoring didn't break anything.
Yeah, and then this is just a cycle that we constantly do over and over and over again. Now, there's one other step that I've heard a lot of people adding now, especially because of Git, and that is it's red, green, refactor, commit.
Commit.
Yeah. So I'm not using source control for this example, so I hope you're forgiving me for that.
Oh, yeah.
So we have something that's testing the good data, but we also know that we can have bad data as well. So we can get a result that is null. It's actually, yeah, that's a null. It's not quoted.
Right.
And a status that says error. So let's see what happens when we run this through our method. So again, I'll just paste this into our little helper website to escape this. And we'll head back to our code. I'm going to create a new value up here called bad data.
So this last test that he wrote was about, just to keep everybody up to breast on this, the last test that he wrote was the good path. Now he's going to be writing the sad path. So if you've ever heard those terms before, the good path, sad path, this is what he's essentially doing. He's writing the sad path now.
And this is going to look very similar. So public void and parse JSON sunset value on bad data. And I'm going to say I want this to throw an argument exception.
Oh, okay.
Because I'm passing in, because again, this is parsing a JSON string. And so I'm obviously passing in a JSON string that doesn't have the sunset value, or at least the sunset value where we expect it to be.
Right.
So our we can actually use the same action section here. So I'm just going to copy this down. And instead of passing in good data, I'm going to pass in bad data. Now, this is where things get fun because I want to say, I want to check for an argument exception. But how do I check to see if this throws an exception? Well, first of all, let's just see what happens if we try to run this test in its current state. And we see we actually do get an error when this tries to run. But you'll notice that we have a runtime binder error. And if we go back to our code, that makes sense because it's that same thing we saw before where this doesn't actually exist in the JSON content that's coming back. But it's like, well, I don't want to check for a runtime binder error. I want this to actually throw an argument exception. So what I'm going to do is I'm going to wrap this in a try catch block. And again, I'm a lazy developer, so I'm going to highlight this, use the keyboard shortcut Control-KS, which is the keyboard shortcut for surround with. And then I'm going to type in try for our snippet for a try catch block. And that just stubbed that all out for me.
Nice.
And again, I'm trying to catch an argument exception here. And we'll go ahead and pull this back. But now we kind of have to tell our code kind of what's successful and what's failure. Now, if I do get an argument exception, this is the good state. So I can say assert.pass. Now, technically, we don't have to put in assert.pass because anything that doesn't fail passes by default, which is something I don't really like, but I understand why unit testing frameworks do that.
Yeah.
Now, the other thing is, what if an exception is not thrown at this block? Well, at this point, I want to say assert fail and say argument exception was not thrown. So if for some reason this block of code doesn't actually throw an exception, then I want this test to fail as well. So right now, there's two ways that this test could fail. The first is if it throws no exception at all, it's going to hit this assert.fail block to say, hey, you're supposed to throw an exception, you didn't. The second way that this test can fail is if it throws something other than an argument exception. So if it throws something other than an argument exception, then that again will show up as the error that we've already seen. So if I rebuild and let the test rerun, we'll see we get exactly the same failure because this is saying, hey, a runtime binder exception was thrown. This is not the exception that you're looking for. Does that make sense?
Absolutely. Yeah, you're really testing multiple things with one test here, even though you only need one assert to do it. You're essentially testing, you know what you want. You want an exception of type argument exception. That's what you're going for. But there's potentially many different things that could throw this off. You might get a different type of exception, or you might get something back from as part of your result, which it shouldn't be able to. It shouldn't be able to parse the data for you in its current state.
Right. So now we can come back to this code. And again, I'm going to wrap this in a try catch block. So I'll do the same thing, Control-KS, try. And in this case, I am going to catch that runtime binder exception.
Now, just to make sure everybody knows, he's in the red state with his test. So he's trying to build the class so that it matches and makes a green passing test.
And so in this case, if it does throw a runtime binder exception, then I know that this, again, sunset isn't in the right place. So I will throw an argument exception. So we'll throw a new argument exception. And in this case, I'm going to say invalid JSON object. Or actually, let's say JSON object does not contain sunset. Be a little more specific. And then I want to give some clue as to the value that's actually coming in case I need to do some debugging. So for this, I'm going to use a string literal, or not a string literal. I forget what these things are called. Do you remember what these are called, where you can pass in this rather than doing the string.format?
Oh, I'd have to go look it up. I know what you're talking about. Yeah, you're essentially, it's not a string literal because...
Is it string interpolation? Is that what it's called?
I think that's right. Yeah, I think that's
okay. So string interpolation. So I can pass in this JSON content value, which is the parameter coming in. without having to do a string.format and putting in a placeholder and that kind of other thing. And that magic happens because I $signed this guy here. So at this point, if I go ahead and rebuild, I should get a passing test. And I do. That's good. Woohoo! I like to see that. So that means we are throwing an argument exception, and the runtime binder exception is not floating up like it was before. And then if we wanted to go a little bit further, we could even grab this exception and look at what's inside of it. So we can look at the message or the parameter name to make sure that this is the correct exception. So this is not using any of the special NUnit stuff. And I did that intentionally because I do want to show that dealing with exceptions isn't that hard once you kind of understand this basic layout where I have a try catch block, and then inside my try I have an assert.fail. So if I don't get an exception, I make sure the test fails. And then inside the catch block, again, I technically don't need this assert.pass, but if I wanted to go in and take a look at this exception a little more, make sure that this is being thrown on the right argument, then I can make sure that the correct exception was thrown and not just an exception was thrown.
Right. Yeah, you can do it. You don't have to have, because I think what you're going to get towards here is that NUnit has the built-in checks to check for exceptions as an attribute that you can put on there. But you can't really, with like MS test or whatnot, you have to use this try catch block.
Yeah, so actually the attributes are gone.
Oh, are they really?
Yeah. So MS test actually had attributes where you could see if an exception was thrown, but you couldn't get any details about it. NUnit deprecated that, and so it's actually no longer available in NUnit 3.0.
Oh man, I gotta update my libraries. Although that's gonna break all my tests.
Well, as soon as you update to NUnit 3, you'll see all the broken stuff.
Oh boy, when did they do that? You said,
and then if you want some more information, I actually have a one of my TDD videos that I have on YouTube right now actually shows kind of all three different ways of doing exceptions, with the attributes, doing it manually this way, and using kind of the built-in NUnit stuff. So I'm not going to go into the details of that today because it's not really important to the TDD nature of what we're doing right here.
Well, and I kind of actually prefer this in a way because, this doesn't really matter which testing framework you're looking at. This is C# code that you're doing.
Right, exactly. Okay, so we've tested our happy path and our sad path for our getting the sunset value. The next thing we have to do, if we were to go back to our steps here, so we've kind of checked off this first, or not the first one, the second one, but then we want to convert that value into a date time. And so let's just go ahead and TDD into that, very similar to the way that we parsed the value out. So in this case, we'll say public void, and I'm going to call this toLocal time because that kind of sounds like a good thing to do. And let's see. I want to give this a name of, say, onValidValue. Turns expected date time.
And again, I just want to reiterate with everybody, you don't have to know the names of these tests right off the bat. I often find myself just calling them foo and then figuring out what I want my test to do, and then go back and rename my test now that I know what it is that I'm actually making the test for. So don't feel intimidated like you have to know the names of these tests right up front.
Yeah, and I'm kind of torn on that because I definitely go back and rename things all the time. But I'm also at the point where if I don't know what I'm calling something, do I know what code I'm trying to write? You know what I mean? So it's I think there's a happy medium in there somewhere.
Yeah, give yourself some. I understand you're kind of giving yourself at least some idea what it is you want to do, and then just go back and rename it. I don't know. For me personally, I feel like if I set myself to naming something, I don't like to go back and rename it too often. I just kind of want to have a very generic, I call it food just because I don't feel obligated to that name yet. I don't feel obligated to what that is just yet. And I don't feel like I'm setting myself up for any failure right off the bat. But you're right. It's a personal choice. You could certainly be. I could understand if you don't know what to name your test yet. How do you even know what test you're writing? Well, I guess I just kind of feel like I figure that out as I'm writing it, if that makes any sense.
Yeah. Well, hopefully you know the test you're writing, even if you don't know what to call everything yet.
Right. Yeah. And sometimes I have to work through, I'm thinking through what is the behavior that I want? Because that's essentially what I'm doing is I'm trying to write out my tests to think about what is the behavior I'm trying to get out of this. So I may not know the name. I may not even really know the exact behavior just yet. I'm writing the test to try to figure out that behavior. Do I want it to return a string? Do I want it to return an int? Do I want it to return an object that I need to go and create later? I don't necessarily have to know all of these things. I'm sitting there using testing framework as a way to kind of figure that stuff out as I go. And that's the wonderful thing I think about TDD. And I guess not everyone uses it in that particular way. I like to be open, like this is a whiteboard to me. This is where I'm going to discover what my code is going to look like and how I'm going to make my interfaces, come back, or my methods in my classes. This is where I'm going to figure all of that out. It's my whiteboard, essentially. It's not something that I've already have to have everything nailed down and pinned down exactly what I want it to do right off the bat. So just a little difference, I think, there.
Yeah, and I'm actually the opposite. I have a real whiteboard that I scribble on all the time. So I like to know kind of the direction I'm headed in before I start writing code. So there's been some interesting stuff about that recently. I won't get into the controversy. We can talk about that later.
I know. TDD is one of those real controversial subjects if you
yeah
really into it.
But I'm a whiteboard person, so I don't plan everything out in advance, but I like to know the direction that I'm headed in.
Yeah.
So in this case, we're going to have a date time as a result that's coming back from this method that we want to create. And again, I'll just create this as a static method on our current object that we have, and I'll call it toLocalTime. And then we want to pass it in the time string that we're getting from JSON. But I also kind of need some more information, right? Because that's just the time. It doesn't tell me what date we're working with here.
Right.
So in addition to the time, I also need to pass in a date value of some kind. So in this case, I'm going to create another variable. And we're going to set this to a new date time. And again, since we're using November 30th, we'll just go ahead and use that for our sample. And then what do I expect to get out of this? Well, I basically expect to get a combination of these two. So I'm going to set my expected to a new date time, which has 2016, 11:30, and then the time, which will be 16:42:49. We convert that into 24-hour time. And then I can check to see if those match. So again, R equal, expected, and result. Now again, this toLocalTime method has not been created yet, so we'll get a build failure if I try to build at this point. And again, I'll do the same thing here. I'll hit Control dot. And then again, what we can see here is that Visual Studio gives us a preview of the method it's about to create. So we can see it knows it's going to return a date time value. It's going to have two parameters, a string value for the time and a date time value for the date. So we'll go ahead and stub that out. And again, if we go and look, it created a very useful method that throws a not implemented exception. And if we rebuild at this point, we'll see we get our failing test because this is not implemented yet. Now, like I said, in the original service that I was working with for this, the time string was actually a UTC time, and getting that back into a local time was pretty interesting. to kind of simplify this example, rather than having to deal with all that, I just created the time string as a local time. So our code is going to be a lot simpler than it would be. And it's actually still kind of technically simpler than it should be because, again, date time is weird. So the first thing I'm going to do is I'm going to take my time string and convert it to a date time value by just parsing it. Now, that's obviously not going to get me a valid date portion of a date time, but it will give me the time portion of a date time.
Mm-hmm.
So then what I can do is I can combine the date that's coming in as the parameter with the time that I just parsed out of our string. And so we'll say date time. And let's go ahead and call this result equals, and this is where it gets fun, date dot date plus time dot time of day. So the date portion will, again, in this case, be 11/30/2016, and then the time of day will be the 4:42:49 p.m. It's going to stick those together and give us a result that, let's get rid of that intermediate variable, or just return that. I like simple code. Okay, so hopefully if we build, we'll get a passing test at this point. Woohoo! Okay, I like to see passing tests. And I won't go through the process of putting in an invalid time string at this point, because I kind of know in my code that I'm going to be calling this parsing first, and this is going to return us hopefully a valid string. We're going to assume that it's valid. And so I'm going to assume that if the service returns me a sunset string, that it's actually a real one that I can use. So I'm kind of relying on the service to be stable at this point. Again, kind of how far we want to take this for error checking is up to us, but we could just as easily go in and check, okay, what happens if it passes in something that's not parsable?
Yeah, you're just effectively saying, I don't need to test the sad path of this because it's already basically being tested in another test.
Right. And if I get the date time parse exception, then I can go in and deal with that when the time comes, basically.
Yep.
I also think about the criticality of what I'm building. In this case, for this home automation software, this is not, 5 nines of uptime kind of code. So I might not do all of the exception checking and making sure nothing bubbles up that I might do in an application that's in the outside world and things like that. So there's kind of a lot of stuff going on with that. Okay, so we're able at this point to parse the sunset value from our JSON data, and we're able to convert that to a date time value. Now let's go ahead and see what we can do about, let's not call the service just yet, but let's go ahead and test this get sunset value, or this get sunset method, just passing in some hard-coded values to start with.
Okay,
so we'll say public void, and this is the get sunset, and we'll say on valid date returns expected date time. Now, in this case, I am going to have to new up an instance of the sunset calculator because this is an instance method. So part of this will be newing up a calculator. Boy, I just cannot type at all today. New service sunset calculator.
I think that's the universal truth for all developers.
And then we're going to call the get sunset method, which, hey, we don't actually have to stub out because it's already there. Now we do need to pass in a date time. So let's go ahead and we'll just grab this guy here. Lazy developer reuses code.
Boy, what happened to the dry principle?
When in unit tests,
oh yeah,
I violate the dry principle in unit tests for readability all the time.
All the time.
And I have no problem at all with that.
Nope, I don't either.
And again, this should
I find myself copying and pasting stuff all the time. There is obviously some people that are real sticklers about that too. If you're doing that, you need to make your own functions that do it or something like that. But
Yeah, and I actually have an article on whether we should use setup methods or not. I've actually moved away from setup methods to factory methods because they're less magical and easier to see what's going on. But
Yeah.
again, that's another topic. So
Yep.
this
Oh
does
yeah.
return a date time. So var result equals this. And then again, we kind of need the expected value, which in this case, we'll go ahead and use the same expected value that we used above. Hey, are we cheating? I think we're cheating at this point.
Yeah.
Assert.r equal
We're lazy developers.
expected and result. Well, here's the thing. At this point, if I build, I am going to get a failure, and that's because right now we are throwing a not implemented exception.
Right.
But just kind of step one to get this test to pass, I'm going to hard code this good data string. So what I'm going to do is I'm going to embed this into the test. So we're not going to call the service right now. Instead, we'll hard code service data. Boy. There we go. And we'll just call this service data. And then we can start using the methods that we already created. So we'll parse the sunset. So this returns a string. This will get us the sunset time string from parse sunset. And we can pass in our service data. Wait, staring, that's not even close. Maybe I should just give up right now. And then we can actually get our sunset with the toLocalTime method by passing in our sunset time string that we got from our parse sunset, and then the date, which is actually coming in as a parameter to this method. And then we can return that value. So if I do this, I will actually get a passing test, which is good, but not very useful.
Right.
Because we really should be calling the service itself.
Yeah,
now, this is where I'm going to cheat a whole lot because I have a method that already knows how to do this. And for the time being, we're just going to add it to the bottom of this, and then we'll look at how refactoring can make our lives a lot easier.
Okay.
So in this case, I'm going to create a public method that returns a string, which is our JSON content. We'll call this getServiceData.
We could just imagine that someone else already wrote out this function. It's already been tested. We already know it works. So we're just bringing in something that we already know works.
And like I said, there are ways to kind of TDD into this a little bit. I'm kind of making some assumptions based on the type of application that this is going into. First of all, the latitude and longitude are hard coded in here. And again, that's because this is something that lives in my house and is not going to the outside world. Now, obviously, if I wanted to get these values from configuration or from somewhere else in the application, then I could have some tests that would check to make sure that this string is getting populated okay. Because again, this is basically the string that we need to add on to our service call to get the data. Another big kludge about this particular one is even though I have async calls, I'm grabbing the result properties from them. So this is a pattern which is called sync over async, which is not a good practice, but I'm kind of going to show why in this instance it actually does make a little bit of sense.
Okay.
So now that I have that, rather than getting the service data from here, I can say service data. Try that again. String service data equals service data. And then again, this takes a date, which we already have passed in as a parameter, so we can just do that.
Okay.
Now we'll go ahead and build and let our test rerun. And what we'll see is actually have a failure. And if we look down here at the results from this, we can see that our expected result is 2016, 1130, 1642, 49. but the actual result is 2016, 1130, 1642, 39.
Hmm.
And the reason for that is that these coordinates right here are different from the coordinates that we were using above. So the coordinates that I was using for the testing to get that data, like I said, is the city of Anaheim City Hall. These coordinates that are in here are actually the city of Irvine, which is about 9 miles from here. And yes, Sunset is different 9 miles away.
Yep.
And so what this tells us is we are actually calling the service, and we know that this HTTP client is actually doing what we expect it to do, because that's how this data is getting in. Now, obviously, I don't want my test to be dependent on the service. And so this is where we have to start doing a little bit of isolation. And in this case, I'm going to be using a little bit of dependency injection. So what I'm going to do is I'm going to actually create another class, which I'm just going to put in the same file for simplicity. But again, during kind of the refactor phase, we can move this all around. And we'll call this Solar Service. Good name for our class. And then we can move this method down into it. Now, you're probably upset at me because we are in a red phase right now, and it looks like I'm refactoring, and I kind of am. But now I have to new up this object, so we'll save our service.
I'm just so disappointed, Jeremy. You can't possibly fathom.
Well, when it comes to isolating things, I have enough experience with this and dependency injection, which again is one of those topics. I have a Pluralsight course on it because it was hard for me to learn.
Yes.
That I kind of start out with this isolation. I don't really go this step by step.
Yeah.
Okay, so now.
You know, this is a good example of where, you know, there are there's the folks out there that say you need to strictly adhere to this, you know, the cycle, the red, green refactor. You got to stick to it. But, you know, there's always room for wiggle room here. You need to utilize these tools to the best that you see them for. You know what? I'm not saying that very well. You need to utilize test-driven development in the way that makes sense for you, not just because someone tells you test-driven development needs to be done in this way, this way, this way, this way. That's a good standard to try to start out with, but you're going to learn as you go along that sometimes there are shortcuts to doing things just to help you move things along a little bit faster. You're going to get very well versed in how this works. You're going to realize you don't have to strictly adhere to every single rule and principle to get things done.
Yeah, and we actually need to isolate this code in order to get this test to pass. So that's the interesting bit about this. What I'm going to do is I'm going to go ahead and create a property to hold this service, because we're going to do some property injection. I'm going to use the prop full code snippet. Again, let Visual Studio do the hard work for us. So this will be a Solar service. We'll call the backing field lowercase service. We'll call the property uppercase service. And then what I can do is figure out, okay, where are we going to instantiate all of this stuff? Now, I'm going to use, this is the first time I saw this, I was like, that's really clever and kind of interesting. And this is one way of doing property injection. So what I want to do is I kind of want to make a placeholder where I can use the production service by default, but if I want to swap it out for something else, I can. And so basically, the first thing I'm going to do is move the creation of this service up here. So we'll say if the backing field is null, let's go ahead and new up this Solar service so that now I can get rid of this line here, and then we'll just use the property. So what'll happen is when I call this getSunset method, it's going to pull the service property. And the first time it pulls the service property, it's going to look at the backing field and say, hey, are you null? If so, let me go ahead and new up an instance of this object and assign it to the backing field and then return it. Now, if the backing field is not null, it's just going to return me whatever's in that backing field. So basically, this will create this solar service object the first time we try to use it. And so if I rebuild at this point, we'll see we get the same results that we had before, which is good because we don't have runtime errors.
Right.
So we know that our code is still operating. We're still getting that, slightly off value back from our service. So we know the service call is still happening. But then the next thing I'm going to do is I'm going to add an interface for this service as well. So this is just going to be a pretty simple interface. And I'm going to call it iSolarService. And this will just have the getServiceData method in it. And so what this will do is it'll give us an abstraction that we can deal with so that we can create a fake or a mock object in our unit tests.
Okay.
So because and let me go ahead and rebuild and make sure that everything is still, it's still failing as expected.
Yeah.
If it starts failing in a different way, then we need to worry.
Right.
But then what I can do is I can come up to my property, and instead of this being a solar service, the concrete type, I can give it the interface type.
The interface type. Okay.
And again, I rebuild this code. It still runs. It does everything exactly as expected. Again, still failing. And again, if we don't put anything into this property manually, it's just going to new up this concrete real service for us.
Are you planning on refactoring that out? Because there's a certain, I don't particularly like newing up instances. I'm a dependency injection fiend, so I imagine you're going to be refactoring that out, right?
Actually, in this case, I won't.
Oh, okay.
And that's kind of another, because in this case, I'll use the analogy of using a repository and a service call, because that's kind of what I see this relationship. So a repository that calls a service has to kind of have intimate knowledge about the service in order to function. And it's the same thing here. This service sunset calculator has to have intimate knowledge of this solar service object because it's expecting the JSON to come back in a particular format, So I'm okay with having this, I don't want to say tight coupling, because as we'll see, we'll be able to completely break this coupling in our tests.
Okay. So it's not necessarily tightly coupled. Even though you're newing it up, it's not that it's going to be tightly coupled.
Right. I still have the option. So basically what this is saying is if I do nothing, I will use the production service.
I gotcha. Okay.
But let's watch the magic that we can do in the tests now.
Okay.
Okay. So now what I want to do is I want to mock this up. And I'm not going to explain mocking frameworks in detail because that's a lot of fun. But I am going to bring in another NuGet package, which is MOQ. People say mockq, people say mock, people say it in a whole bunch of different ways.
Yeah, I just call it mock.
Yeah, and so this is a mocking framework that I've worked with. It's worked well enough for me.
Mm-hmm.
Roy Osherov, who's someone I point to about unit testing all the time, he doesn't like it for particular reasons, but I'm okay with that. So what I'm going to do is I'm going to create a mock of this service. And the way that we do this is we use MOCK, which is interesting because it's called mockq, but you say MOCK.
Yeah, MOC. Yeah, that trips me up every time I do it too.
And then again, we'll control dot bring in the using statement for this. And I want to mock up the iSolarService. So basically what I want to do is I want to create this mock is an in-memory object, and I want to tell it what I want it to do, or what I expect it to do when I call a particular method. So in this case, I won't go into all of the details because this is all kinds of fun of Lambda expressions in here.
Yeah.
But what I'll say is if I call the getServiceData method on this object, and then we have to tell it which parameter we're expecting. And in this case, I'll say it.isAny date time. And that's thing really trips people up because that's this is a mock queue specific thing. So
Yeah.
basically, it's saying if someone calls this get service data method and they pass in any date time value, I want you to do a particular thing.
Yep.
Now, what's nice about this is I can say, hey, you know what? If you call get service data and you pass in November 30th, here's what I would like you to do. If you pass in December 1st, I would like you to do something different. So it really opens things up for flexibility when you're testing. In this case, we'll say, I don't care what date you pass me in, I would like you to return our good data. So again, that's that JSON object that we have above.
Yeah, and those of you who are not real familiar with mock or mock frameworks, it's kind of difficult to wrap your head around this if you don't really know this stuff. But what he's essentially doing is he's creating an in-memory instance of this iSolar service. It's not an actual concrete implementation. He's creating kind of a fake iSolar service. And whenever something is going to call on this service mock object, the get service data function, you're going to be able to pass in any type of date time. He's essentially setting up the iSolar service object that he's creating here, the service mock, to have this parameter or this function get service data to be able to accept that date time.
Yes. And then what we can do, okay, so if I rebuild at this point, we'll see we have the same test results that we had before because I'm not actually using this mock that I just created. And here's where the magic happens. Is I say calculator.service, the property on our service sunset calculator object, I'm going to assign it to our mock object.
Okay.
So I'm taking this value here and assigning it to our mock. So before I make any calls, so what's going to happen is we'll call the get sunset method on this object. It'll say, okay, I need the service object. It'll come up here to the getter and say, is the backing field null? And the answer is no, it contains our mock object in memory. And so it's just going to return that and keep going.
Okay.
So it's never going to create this new Solar service inside of our test.
Gotcha.
Because we do this assignment. Now, when I rebuild after doing the assignment, we'll see that now we have a passing test. That's magical, isn't it?
Yeah. Oh, yeah.
And actually, because probably should be a little more explicit like this. Instead of using the is any, I could come in here and say, hey, if someone passes in November 30th, 2016, go ahead and return them the good data because that's really what we're expecting.
Right.
Because our expected output also contains November 30th. So we should actually probably do it this way instead. And again, rebuild and rerun the tests and we'll see that everything still comes out green.
Yep. Always, the green is always good.
Yeah, and there's a lot of directions that we can go from here. We've been talking for an hour and a half, so
yeah,
it's been a long time. But basically, kind of the next steps that I would start doing for this is, first of all, I would look at implementing the sunrise values in exactly the same way. So I would create the parser to pull the sunrise value out of the JSON. We use the same toLocalTime, and then we would have we would populate the get sunrise method that's currently throwing a not implemented exception in the interface. And then I would look at, okay, with these static methods, do they actually belong in this class or can they go somewhere else? And the answer to that in this case is, well, this is kind of a self-contained unit that's not real complicated. So maybe I'm okay with having these parsers inside of this class.
Right.
If it's something that's like, well, you know what, this toLocalTime, I really want to use this in a whole bunch of different places. Then I want to extract that out into its own class.
Right.
You know, this parse sunset, this probably isn't useful anywhere outside of this service call. So in this case, I might be okay with just leaving it in here. And then another thing that I did in the production code, which again, I'm planning on putting this into a video, probably a series of videos on my YouTube channel, is that another thing I'd want to do is add caching. because in the home automation software that I have, this get sunset method that we have up here at the top, this gets called multiple times during the day. Well,
Right.
there's no need to recalculate the sunset over and over and over again because it's going to be the same for today for the entire day.
Hmm.
So the next step from here would be to add a local cache to say, hey, if somebody's already asked for the sunset for this date and you have it in memory, just return that. Don't make the service call.
Right.
And there's ways that we can use the mocking framework to verify that we're only calling the service when we actually need to. So there's kind of a lot of cool directions that we can go from here.
Yeah, there definitely are, and I know you're going to be putting this code is going to be available on your website too, so people are going to be able to kind of go through and look at some of the other stuff that is going to be beyond what we demonstrate here in this video, because I know you've got a lot more content that you're going to go over, and I interrupt too often, so you weren't
Oh,
able
no.
to get to everything I'm sure you wanted to go over to today.
Oh, no, you're doing fine. I mean, this is basically, I kind of plan most of my talks that I do to be about an hour and a half or so, which is kind of a good time span for a user group talk.
Yeah,
And
yeah,
I try to figure out, okay, can I do a 1 hour version of this for like a conference or a code camp that have more restricted time? So I'm usually, kind of targeting about that hour and a half length when talking about these kinds of things, and then making additional resources available so people can explore further.
yeah. Well, and I'm sure that a lot of my users, a lot of my viewers, I should say, not users, they're going to want to be able to look at some of the finalized version of this, so they can kind of work out, okay, how did he get from where we are now at this video, where we just kind of worked on the sunset part, and what did he do in the sunrise section to kind of, kind of compare how they might have come up with it themselves. So I think this is really kind of a good ending point here, so that people can go try to build that get sunrise, build the tests to get the get sunrise working. And I'd say, do the same similar type of thing where he used, your own sample data, where he had that service data string to start with, and then work from there in order to try to build out how you're going to use this get sunrise method. You
Yeah,
don't
and that has
necessarily.
sunrise right in there, so it's already got a value we can use.
Exactly, exactly. So that's really great. Is there anything else that you wanted to kind of go over here before we close out?
Well, one question that I get when I show this, and this is more about unit testing in general. So up here where I'm, parsing the value from our string that we have above, let's see if we can get these both on the screen. So I'm trying to parse this value out of the good data string. So people ask me, so Jeremy, why are you hard coding this value into your test rather than parsing it inside the test? Wouldn't it be better to say, okay, well, my test is going to parse this good data string to get out the sunset value so that I don't have to have this hard coded expected value in here?
Mm-hmm.
And the answer to that is, well, to do the parsing, I would probably end up writing exactly the same code that I wrote here when I
Right.
deserialize the object and pull out the value. If my test code and my code that I'm testing use the same code, they might both be wrong. So I want my test to take a different approach to getting the value than I want my production code to have. And that way I can make sure that it's working properly. So
Yeah,
that's just a question that I've had people ask, especially if I end up parsing the same good data string over and over and over again.
right. And I would definitely agree with that. I think you want to be as literal with your sample data set as possible. If you're trying to make it too modular with your tests, you're really just making the potential for in you can get new things into your tests that you don't really want. You don't want those extra variables that might cause problems. You may think that you're writing these wonderful tests that are all passing, and then something's going to break, and you're going to find out that really the code that your test was relying on was actually broken. So you want to try to be as literal with it as possible. And that's kind of why we have mocks. That's why we have the mock framework. That's why we use string literals. You want to be as literal with what it is you're working with, the exact object that you're working with as possible in your test, as concrete as you can be. But then when it comes to building your applications that consume the values, and you're writing out your classes, your methods, your properties, etc., you need to be getting more and more generalized. You're trying to work away from being as specific as possible.
Yeah, and along those same lines, I want my test to not be tricky. I should be able to walk up to any of these tests and kind of figure out what's going on pretty easily without, digging through mounds of code, and hopefully no reflection code at all. Once you start adding reflection code to your tests, you've pretty much lost.
Yeah.
So,
yeah. And I imagine some people probably tried to do that so that they could do the, check to see if it implements an interface or something like that. And that's not a good path to be going down.
yeah. Okay. So I'm going to stop sharing.
All right.
If you want to look at my ugly mug again, you can.
So did you stick with the No Shave November? I see you've got quite the facial hair there.
So I've had a beard for about 4 years now. So
No Shave November went for a lot longer.
Yeah. Well, I do shave down here. and I trim my beard. I'm a trimmer. I don't let it grow.
For those of you guys that have been watching the channel, you saw that I was trying to grow this out. I felt so bad for my wife. She had to look at my ugly mug with all that facial hair, but I thought I'd give it a try because this is the first time I've ever actually tried to grow it out. But anyway, Jeremy, thank you, man. I really don't know what else to say. Thank you so much for bringing us your presentation. I hope that maybe some of the questions that we asked here could maybe refine some of it, or maybe help you out with trying to, answer some of those questions that I'm sure you'll probably be getting as you're out on tour.
Yeah. And I appreciate the opportunity to share. I'm always looking for new audiences to share with. And, I love helping people. The one thing that I don't like about doing screencasts is I don't get to actually watch people learn.
Oh, yeah.
I love the in-person thing where you can watch the light bulbs go on, because then I know, I just changed that person's life today. And that's the main reason I do this.
Yeah, you don't really have that metric on the analytics for YouTube. It just doesn't exist. The light bulb metric doesn't exist.
Well, I get a lot of the light bulbs in comments, so that's nice.
Yeah, that is always very nice. And for every one of you guys that's watching right now, there's obviously a reason why you guys are watching this channel. I hope that we've put enough light bulbs on for you guys today in this video. This is kind of one of those things. Test-driven development is one of those things that it takes a while to get really, for you to really get right, because it's a difficult discipline to get started in. So I wouldn't blame you at all if you kind of go away, you try it, I don't really like it, and then you come back to it a month or two later, okay, I'm going to try this out. You really got to keep plugging away at it. And then I think when you really start getting into it, test-driven development is one of those things where it becomes kind of a security blanket. You feel comfortable because you know that I'm going to run my tests. I'm going to click that button. I'm going to see green, and I'm going to know everything works. And that's the wonderful thing about it, is you just know every single time you click that button and you get green, your application works. And you can rely upon it. It's fully tested. All your unit tests are already written, so you don't have to try to go back and rethink how you're doing things. You don't have to write tests to try to recreate your methods and your classes to try to match up to this new feature or something, and then end up breaking something somewhere else. You don't have to try to do all that later. You can actually do it right up front. It helps you plan out your applications, helps you plan out especially your business rules in a way that I think is very healthy and iterative, and makes you very satisfied. Every 30 seconds or so, you click on that button, there's your result. You know what you're getting.
Yeah, and another thing that I've heard people talk about with TDD in particular is, we're usually not working on one-day projects. We have to come back day after day. And so I've heard people say at the end of the day, they'll leave a failing test before they walk out the door. So when they come in the next day, they'll know where they left off. And obviously,
Really
that's
cool.
not something you want to check into your source control. You don't want to check a failing test into source control. But if it's something that you have just on your machine, you walk in the next day, it's like, oh, okay, here's what I was working on. Let me see if I can get this test to pass. And I've heard it helps you get back into the groove of where you were.
That's fantastic. I really like that. I might have to start doing that myself, because usually I try to make all my tests passing before the end of the day, and then, like you said, I do a commit too. Obviously, at the end of my day, I always do one last commit to make sure I get everything up to date. So, well, thank you so much, Jeremy. Would you be willing to come back on the show and do one of your other presentations?
I'd be glad to. I'm always up to show cool stuff.
That's amazing. Thank you so much, and I look forward to having you back then, because I think, especially, you were talking about the dependency injection stuff. I'm about to get started on covering dependency injection in ASP.NET MVC in the ASP.NET Core stuff. So I think dependency injection would be a really great topic for another talk.
Yeah, I'd be glad to do it. That's one of my favorite ones. And I'm not in the web world, so I show examples in desktop, but it's more the concepts of why it's important and the loose coupling that really kind of makes you understand, oh, here's what's going on. Now I understand what the containers are doing. It's not magical anymore. And
Right.
Once it becomes not magical, you can do cool things with it.
Yeah. And I love the fact that with ASP.NET Core that they built dependency injection right into MVC. It's no longer a third class citizen. You don't have to bring in some extra library to manage it for you. It's built right into MVC. So that's fantastic to me. Anyway, so thank you so much, Jeremy. Again, I really appreciate it. And again, if anybody wants to get a hold of Jeremy, he does do these talks all across the US and in other parts. I think you've done some in Canada before too, haven't you?
I haven't been to Canada. I have been to London and Oslo.
There we go. Oh yeah, you do the conferences. Of course, you've been to London and Oslo.
Yeah, I'm
did you
headed back
do the
to
one
London
in Australia? Did you do the one in Sydney?
I did not do Sydney. I didn't submit for it because that's another long flight. So it was, I was on enough airplanes this year. So I might try to get into Sydney for 2017. That'll be fun.
Well, so if he's going to be in one of your towns, you can go to his website, jeremybytes.com, and you can see what his schedule for upcoming in December is. I don't think you have anything beyond December at this point, do you?
Right now, the only thing I have on my schedule is I'll be at VS Live Orlando, which is next week. So if you're watching this video later, you missed it. And I'll be at NDC London in January. I don't have anything firm on my schedule right now, but my 2017 is starting to materialize. As soon as stuff does get confirmed, it pops up on my homepage. Okay,
great. Yeah, so just keep an eye on his website. He's got some great stuff. Like I said, he's one of my favorite guys to listen to on Pluralsight and watch, because he's got such great content. And always the test-driven development stuff is always fascinating to me too. So anyway, thank you guys, everyone, for watching. I hope that you guys enjoyed what Jeremy was able to deliver for you guys today. And if you guys have any questions about test-driven development, you can send him a message on his website. You can drop him a comment in the comment below this video. And I'm sure both he and I will keep an eye on the comments in this video in case you guys have any of those questions. Until then, is there anything else, Jeremy, you want to say to my audience before we cut this off?
Happy coding.
All right. Thank you so much, guys. Thanks, everyone, for watching. You guys have a wonderful rest of your day.